P4.3 Potential Difference and Resistance. Before I start, I just want to remind you of the definition, what potential difference actually is. So potential difference is a measure of work done or energy transferred to a lamp by each column of charge that passes through it. The unit of potential difference is volts. Okay, so I'm just going to start off by showing you a circuit diagram. We can see some of these components are in there. They should be familiar to you from last lesson. This symbol represents the ammeter. This represents a battery because there's two cells joined together. This is the positive terminal, where the bigger line is that side. We have an indicator, which is often a bulb, and we have a voltmeter, which measures potential difference. I just want to remind you that a series circuit is one loop, parallel has branches going through it. So, in the circuit diagram above, the battery forces electrons to pass through the ammeter and the bulb. The ammeter measures the current through the torch bulb. It is connected in series, so it's in the same loop. So sorry, you can see that. So this is one loop going round. It is connected in series because it's connected in the same loop. This voltmeter is parallel to the bulb because it's not in this main loop. So the current across them is the same. If something is in series, the current going across them is always going to be the same because it has to go through somewhere. Remember, electrons will not travel around the circuit. If the circuit's broken, it all needs to be connected, otherwise the electrons won't transfer. So in a series, the electrons have to take the same route going all the way around, so exactly the same current goes through each component. The ammeter reading tells us the current in amperes for small currents. So there's two different units for amperes. There's milliamperes and amps, and 1 milliampere equals 0.001 amps. A voltmeter measures the potential difference. Potential difference might be written as PD or voltage across the torch bulb. In this this is the energy transferred to the bulb or the work done by each column of charge that passes through it. The unit of potential difference is volts, and volts, the symbol for volts is a capital V. The voltmeter is connected in parallel with the torch bulb, so it measures the potential difference across it. So going back to the diagram, this is the torch bulb. The voltmeter is only measuring the potential difference for this section of the circuit. The voltmeter reading tells you the potential difference of volts. So when the charge flows steadily through an electronic component, so a bulb for example is a component, this is the equation we can use to work out the potential difference. So again, we've got the letters that represent the words for them. So potential difference is represented by a capital V, energy transferred by a capital E, and charge is a capital U. Now each of these things have units. Potential difference is measured in volts. This is also represented by a capital V. Energy, the unit for energy is joules, represented by a capital J, and the energy for charge is coulombs, and this is represented by a capital C. So this is the equation we can use. You need to make sure you can use this equation and know what it is. Okay, resistance. So electrons passing through the torch have to push their way through lots of vibrating atoms in the metal filament. So remember, the filaments are wire inside of the bulb. The atoms resist passage of electrons through the bulb. So the more these wires or filaments vibrate, the harder it is for the atoms to get through, so the resistance is higher. The resistance of an electronic component can be worked out using this equation. Again, we've got letters representing the words. So current is I, potential difference again is V, resistance is capital R. The units for resistance is ohms, represented by this Greek symbol. When for volts for current is measured in amps, and that's represented by capital A. They're the units you need to use. Remember that a resistor limits the circuit current, so it can control how much current goes through it. Current potential graphs. So I'm going to introduce a law to you, so Ohm's law, and this states that the current through a resistor at a constant temperature is directly proportional to the potential difference across the resistor. So this means that if the potential difference doubles, so does the current. that is what direct proportional means. They go up in sort of like the same amounts, or go down by the same amounts, or in the same pattern even. So this graph will help to explain it. So we've got potential difference going across the bottom and current going up the side. We can see this is a straight line, so it's directly proportional if it's a straight line. So this graph shows the relationship between current and potential difference. It's a straight line and goes through the origin. This means that the current is directly proportional to the potential difference, i.e. they increase and decrease in the same pattern. So if potential difference doubles, so does current. The gradient, so how steep the line is, depends on the resistance of the resistor. The greater the resistance on the resistor, the steeper the line, so it's the harder that it is for the electrons to move through.